All right, I wanted to go ahead and review these bar graph problems that I gave you for homework about a week ago. And just a couple of things that we want to review just to make sure that we're absolutely clear on things. So whenever we do conservation of energy problems, we're always going to have an initial situation and a final situation that we use to set up our equations. And that's exactly going to be the case here for every single one of these problems that we do. And just to keep this in mind, we have some identifiers for when we see the various types of energy that we're going to label. And so remember, we have EK, which is kinetic, that's moving, EG, that's gravitational energy, and we require a gravity field and height for that. And then we have elastic energy, which is the energy we have whenever we encounter a spring. Now, after a process has happened, there may be energy that gets lost to the system. It still exists, but it is energy that we can no longer access, and that's called dissipated energy. It usually gets dissipated in the form of heat, sound, possibly light, other things like that. So what we're basically going to do is we're going to be using some criteria to identify those energies, and then we'll actually be doing this in the problems to set up our equations once we identify the types of energy. So the first thing to note, when do we know there's gravitational energy? It's when we have height or elevation. When do we know there's kinetic energy? When we have some kind of speed. We have elastic energy whenever there's a spring, and dissipated energy happens whenever we have friction or drag or air resistance. You'll also hear the word heat. Okay? So just to kind of now go ahead and identify energies and set up our conservation of energy equation from the bar graph. So we are told we roll from rest. There's no friction. And we're going to use these facts to begin the problem and set it up. So we start from rest. That means we have no kinetic energy at all. We're on the ground, so to start with, at position A, we have no gravity energy because there's no height. So I'm actually going to write this down. I'm going to write V equals 0, H equals 0, and I'm going to note that there's a spring. So no speed, no kinetic, no height, no gravity, spring. So what this tells us is that all of our starting energy is stored as elastic energy here. And I'm going to draw 4 little blocks there to kind of note that that's the amount that we start with. Now, the rule for conservation of energy says that the energy you begin with equals the energy that you end with. Again, I for initial and F for final. And we're going to eventually set up this equation using the bar graphs here to give us specifics. So we start off with all elastic. Now what do we end with? Well, we notice that we're very high up, so height is greater than 0. We also notice that we're moving, so speed is greater than 0. And we don't have a spring, and we don't have dissipated. So since we're as high as we can possibly go on this loop, I'm going to give it 3 blocks of energy, and then I'll give 1 block for kinetic, as we've discussed in class. So now, what we're going to do is we're going to set up our equations using initial and final as our guides. So basically, we're going to set these bar graphs equal to each other. And here's how. So I have E elastic to start with, and that's going to equal E kinetic plus E gravity. And that's our idea. All right, for number 2, it's a very similar thing, but we now have friction, which means we have dissipated. So keeping this in mind, we have no height, we have no speed, but we do have a spring. And here, we do have speed, we do have height, and we are told that there is friction. So what does this tell us? We have no height, or we have no movement or height to start with, so all of our energy does start as elastic. And where does it end up? Well, our height in number 2 is the same as the height in number 1. So I'm going to give it 3 bars of energy again. What this means is since I've got 4 total bars here, I need 4 total bars here. So I'm going to give half a bar to the kinetic energy. And then dissipated energy is the energy lost to friction. It exists, but we can no longer get to it, so I'll shade it in. When we set up our equation of E initial equals E final, well, on the left side we have all elastic, and that gets converted into kinetic, gravity, and dissipated. So that's a review of problems 1 and 2, and then I'm going to take a look at the actual homework in the next video.